Hi friends, in this video we'll talk about the nth term of an AP. If you remember, in the last video we discussed about what an AP is, and we discussed what is the general form of an AP. The general form of an AP is A plus D, A plus 2D, A plus 3D, and so on, where A is the first term and D is the common difference. Also, D could take a positive value, a negative value, or D could be 0. Now building on from there, we'll talk about the nth term of an AP. Now nth term is nothing but a generalized term of an AP. Say we are given the first term A and the common difference D of any AP, and we are asked to find out the nth term. How can we do this? Let's look at it with an example. Suppose Mrs. Sharma donates 8,000 rupees to charity, and she decides that she wants to increase this amount of 8,000 by rupees 500 with each passing year. That means in the first year she donated 8,000 rupees. In the next year she would donate 8,000 plus 500, and in the following year she will donate 8,000 plus 500 plus 500. If you observe closely, the first year amount is rupees 8,000, next year it would be 8,500, then in the next year it would be 9,000, and so on. Now this is nothing but our arithmetic progression with a common difference of 500 and the first term 8,000. Now if we are asked to find out that what will be the amount that Mrs. Sharma will donate in the fifth year, how do we go about that? First year she donated 8,000 rupees. Second year she will donate 500 more, that makes it 8,500. In the third year she would donate 9,000, which is 500 more than the previous year, that is 8,500. In the fourth year 9,500, and in the fifth year, which is the required year, she would donate 10,000. Correct? Now we can see that every year there is an increase of 500, again 500, again 500, and 500. So to find out the amount in the fifth year that she donated, we see that there is an increment of 500 4 times. So we could have directly found out what would she have donated in the fifth year just by adding the increment value, that is 4 times 500, to the base amount, that was 8,000, and we would have got 10,000. Now this is very helpful when we have to find out what she would have donated in the 15th year. Now if you were to calculate by adding 500 every year, it would be a very tedious process. So we see that if we had to find out for 5th year, there were 5 minus 1, that is 4 increments. For the 5th year there were 5 minus 1 increments, that is 4 increments of 500. Now if we were to find out for the 15th year, we can see that there will be 15 minus 1 increments of 500, that is nothing but 14 increments of 500. And if you add this to the base amount, that was 8,000, we would get the amount that she would have donated in her 15th year. That is equal to 14 into 500 gives us 7,000 plus 8,000 and a total of 15,000. So this is the amount that she paid in her 15th year. We can see that this is the 15th term in the AP. The AP was 8,000, 8,500, 9,000, 9,500 and so on. The 15th term, which can be denoted by A15, is nothing but 15,000. And the 5th term, that was A5, was 10,000. Now I think you see a pattern here. We see that if we are to find out the nth term an, there would be only n minus 1 increments of the common difference d added to the base amount of the first term, that is a. Now this is what we use to find out the nth term of any AP. That means nth term of any AP is equal to the first term plus n minus 1 times the common difference. We can see that we are making n minus 1 increments because there was no increment in the first time. The increment started from the second time. Hence, there would have been n increments if it would have started from the first term, but since it starts from the second term, we have only n minus 1 increments. Now you can find out the nth term of any AP whose first term and the common difference you know by using this relation. Now let's look at a few examples. Find the 10th term of the AP 2, 7, 12 and 17 and so on. Now we know that the nth term of any AP can be written as the first term plus n minus 1 times the common difference. We can clearly see that in this AP the first term a is 2 and the common difference d would be 7 minus 2 or 12 minus 7 or 17 minus 12, that is nothing but 5. Now we have the values for a and d and we are supposed to find out the 10th term. So just plug in the values of n, a and d in this relation, that is a10 or the 10th term would be equal to 2 plus 10 minus 1 into d, that is 5. That becomes 2 plus 9 into 5 or 2 plus 45, that is nothing but 47. So we see that the 10th term of this AP is 47. Now let's look at another example. If this AP is given to us 21, 18, 15 and so on, and we are asked to find out that which term would be minus 81. That means that minus 81 comes in this list somewhere down the line, but we don't know where. So we are supposed to find out what term that would be. Again, it's clear that the first term is 21, that is a. The common difference d would be 18 minus 21 and not 21 minus 18, because 18 comes after 21. So 18 minus 21, that is minus 3. Now we know that the nth term an is minus 81. Hence minus 81 would be equal to a plus n minus 1 into d. That implies minus 81 is equal to A, that is 21, plus minus 3 into n minus 1. This means negative 102 is equal to minus 3 times n minus 1. We can further go on to say that 102 by 3 is equal to n minus 1, or n minus 1 is equal to 34, and hence n would be nothing but 35. Hence minus 81 is the 35th term of the given AP, that is 21, 18, 15. Now let's look at another example. Determine the AP whose third term, or A3, is 9 and the seventh term, or A7, is 17. Now when I ask you to determine the AP, that means nothing but finding out the first term A and the common difference D. If you remember from the last video, if you know the first term and the common difference, you can find out any term from the AP. So let's start. We know that the nth term an can be written as n minus 1 into d plus a, the first term. Let's assume that this AP has a first term a and a common difference d. That means a3 is equal to a plus 3 minus 1 into d, and we know that it is equal to 9. Also a7 is equal to a plus 7 minus 1 into d, which is equal to 17. These values are given to us. Now let's call this equation 1 and this as equation 2. Now we see that we can eliminate a from both these equations just by subtracting equation 1 from equation 2. That gives us 7 minus 1 into d minus 3 minus 1 into d is equal to 17 minus 9. You see that when you subtract, a and a would get cancelled. This in turn gives us 6d minus 2d is equal to 8, or 4d is 8, and hence d is nothing but 2. And if you substitute d as 2 in either of the equations 1 or 2, we'll find a plus 2 times d, that is 2 again, is nothing but 9. This gives us a as 5. Now this brings us to the end of this video. In the next video we'll see a few more practice examples, and that will make things clear for us. Bye.